myself as the third presenter, and please let me know if I'm running out of time. Today I'm going to talk about the safety training for scaffolding and formwork construction by using the virtual environments. The lead author is my PhD student, so I would like to credit his work. My outline for today's presentation, I'll start with our motivation why we picked scaffold and formwork activities. I will briefly talk about the safety training effectiveness and the role of virtual environments in that sense. I will state our research aim, talk about our methodology and contributions. As we have seen in the earlier presentations, construction industry actually plays a very significant role in the nation's economy. For example, in the United States, around the economy, construction economy is around 717 billion US dollar, which contributes around 4%. And in the 28 European Union countries, it is around $890 million. And as you all know, since this construction industry is evolving, one of the most frequently used construction equipment is actually the scaffold. Scaffolds are the temporary structures that are used to support a work crew or the materials during the construction or erection or decoration or the facade work. You see a picture on the left-hand side of a scaffold supporting the formwork, and the right-hand side it is a facade work with improper, obviously, application. And around the world, no matter whether it's a developing country or a developed country, we come across with several accidents related or during the scaffold or formwork activities. As you can see some examples from Australia, India, or China. And according to these statistics, in the United States, 937 fatal accidents occurred in 2015, and 79 of them are occurred during the scaffold activities. And in the United Kingdom, approximately 217 injuries occurred, and 97 of them occurred again during the scaffolding activities. So our motivation is because of the lack of knowledge, or basically because of improper safety behavior, or improper lifting, lack of precaution during the design, or poor risk classification. It doesn't matter. We can just extend this list. Accidents occur on the construction sites, and unfortunately, some of them are fatal accidents. So, which brings us to human-oriented factors are actually have the greatest impact on the accidents during scaffolding and formwork activities as well. Therefore, if we can provide an effective training to those workers, then maybe it is possible to mitigate those accidents, number of accidents, or even it might be possible to prevent the fatal accidents. So how can we define actually, let's look at the training effectiveness, not necessarily from the safety perspective, but in general. According to Kirkpatrick, he defined 4 important parameters for a training to become effective. The first parameter is the reaction, the second one is learning, third one is behavior, and the fourth one is the results. So it is important actually your trainee like the training that you provide. If they do not enjoy, if they don't like it, they are not going to pay attention. So your training will not be useful at all. The learning, what principal facts and techniques were understood by the trainees. So can you provide information transfer or knowledge transfer, even more importantly? Behavior, how the participants adjust their behavior based on the training. Because if they do not change their safety behavior at all, then it means, again, your training is not useful. And finally, the level of achieved examination result of the participants, again, is an important parameter to consider for the training effectiveness. A more recent study, which was conducted by Burke on top of the Kirkpatrick's definition of training effectiveness, he focused on safety training effectiveness, And he grouped safety trainings in 3 categories. The first category is the least engaging safety trainings. The second one is moderately engaging ones. And the third one is highly engaging. Obviously, if your training is, if you want it to become effective, it should fall under the highly engaging category. But guess what? In the construction industry, most of the time we come across with least engaging safety trainings, which only focus on information transfer, which includes providing, for example, books, lecture notes, videos, and photos. Moderately engaging safety training cover the least engaging one, and also on top of that, it involves some questionnaires and interviews, so you start to get some feedback from the trainees. However, in the highly engaging category, you provide both information and knowledge transfer. You look at the behavior modeling, so you make sure that people actually change their behavior accordingly. And the most crucial part, I assume, is the active hands-on training. But then we have a problem. Having an active hands-on training on construction site might be quite risky and costly for most of the construction companies. So what can we do? What we can do is we can utilize virtual environments, risk-free zone, and relatively cheaper, let's say. And there's so many studies, and many of those researchers are here with us today, and they develop various environments to be able to provide safety training in a risk-free zone. So the aim of our research is, the overall aim of our research is actually to develop a highly interactive and highly engaging safety training tool called VSAFE, and VSAFE stands for Virtual Safety Analysis for Engineering Applications, and discussing how the highly engaging training method could be addressed by the key features of virtual technologies during scaffolding and formwork activities. Here is a snapshot of the second version that we are developing currently. The first version was based on Unreal Engine, but we had some problems with development problems, so again we switched to Unity. Right now the scaffolding and formwork part is developed based on Unity, and I have a very short demonstration for you. Thank you. You found address one of the drawbacks of using serious games, and he mentioned that actually there is no training part. Actually, in this study, we try to address this disadvantage of using serious games, and we first prepare a training part for the trainees. Meaning that they are going to be, the first part, the training part, will be a single user part, and all the other users will act normally, and the system itself will guide the trainee to act in the correct safety behavior. And if, so there will be some pop-ups that you see there in Turkish, but we are going to have the English version. And as you can see, there is a flashing object. Now in Turkish it tells what to do to the trainees. So there's no way actually to make a mistake in this first training session. Once the training session is completed, then it will be the second part, the testing part basically, will take place. So now they are moving to, at the end you saw the movement of the formwork materials from one plane to another. Okay, so let's look at our framework. We started with the development of the scenarios, which we finished. Then we started the integration of the safety training procedure into those scenarios. We also completed that part. We nearly finished the development of the pilot training model with autonomous agent. By autonomous agent, I mean that in this scenario we have 3 players. So only one player can be the trainee, and the other two players are actually managed by the autonomous agents. Once they successfully complete the training part, now the second part, the testing part, takes place. But in this one, there will be two different testing parts. Either three of the roles can be managed by different trainees. This is one option, without having any autonomous agents. And in the second testing option, we may provide actually two autonomous agents with one trainee, meaning that we can actually control the action of those autonomous agents. And for that, we collected real accident data from Turkey, and we now know the percentages of some risk sources that occurs on the construction site in Turkey, and we are going to assign those probabilities to those autonomous agents. So with this way, there will be some possibilities of having accidents, and trainees will be able to actually observe them in a risk-free environment. To wrap up, we can actually summarize the benefits of using VSAFE in four main categories. Since we use a virtual environment, the spatial awareness and sense of reality is much higher, obviously, compared to traditional methods. We have the autonomous agent support this time, meaning that we can actually reflect the real probabilities of accidents to the scenarios. We provide instructional feedback. So each trainee, based on their performance in the testing section, there will be individual feedbacks provided. And we hope that the system actually will help them to change their safety behavior. And their performance will be automatically evaluated. So it is not going to be manual preparation of the feedbacks or the performance score, but the system itself will do it automatically. So basically, because of all those features of the VSAFE, we claim that using virtual environments, a tool like VSAFE, provides highly engaging training for scaffolding and formwork activities on the construction site. Since we can provide information and knowledge transfer, we provide feedback, individual feedbacks, and we provide hands-on training in a risk-free environment, and which helps them to change their behavior, safety behavior. Safety management is a complex task in construction projects. Conventional learning methods, most of them that falls under the least engaging category, really fail to address the real needs on the site. So that's why we recommend using virtual environments for the safety training purposes, and which can be applicable in scaffolding and formwork activities. Thank you so much for your attention. I would like to take questions if you have.